Hi, and welcome back to my channel. So in this episode I'm pretty excited because I just received this dummy load. So this is a 12 watt dummy load, which is supposed to be working well from 0 to 7 gigahertz. And it's by Radiall, so the part number is 6310. So I'm pretty excited about this. I bought it from a ham operator here in France. Oh, by the way, let me also mention that this radio operator was very nice, and he also provided me with this information, so this might be interesting for those of you who live in France or in Belgium, French-speaking countries anyways, that there are some courses streamed on radio every morning, at least Paris time, at 8 o'clock on the 80 meters band at this frequency, or at 9 o'clock in this other frequency on the 40 meters band. So I will definitely, when I get an antenna, I will be able to listen to these frequencies. I will try to follow these courses because I want to become one day a ham radio license operator. Okay, but anyway, so this ham radio sold me this for a good price, and I'm very happy because I waited for quite a while to find a good opportunity. The fact is that I was searching for some dummy loads, and basically there are two categories you can search. One are dummy loads conceived for just HF, so from 0 to 30 megahertz. But these are pretty bad, as some comments here say, for example, that just already above the 50 megahertz they start working very poorly in terms of reflections and stuff like that. On the other hand, you have precision dummy loads that work well up to 10 gigahertz or even more. But you see, for just 25 watts, they can cost 250 euros. So it's not so easy to find good opportunities here. And I'm very happy about this. It's just 12 watts, but it's all I need. And I don't plan absolutely to ever transmit on more than 10 watts. I'm more interested in digital modes. So with those type of communication, you can have a very big range with just 5 or 10 watts. So anyway, I want to check now if this works well and in terms of reflections, and so this is supposed to be a precision device, the same class basically of this mini-circuit here. So this is for 24 watts, but mine is for 12, but it should be a precision device, okay? So for example, the data sheet for this mini-circuit $250 device is that it should have a reflection return loss of about a minimum reflection loss of, typical rather, of 30 dB. And so I also went to the official website of Radiall, and I couldn't find my model, probably because it's quite old, on their, in their manual, in their list of products. But anyway, you also get similar things like the minimal return loss is, supposed to be around 17, and of course it depends on the frequency you operate at, but so these are the values. So I would like to check them using my spectrum analyzer. So here I will only be able to check from the range from 0, or well, let me actually put a frequency starting from 0.1 megahertz, 0.5 rather, up to 250 megahertz. And the reason is that to perform this test I will use this directional coupler that works, it's from Mini-Circuit. I don't know if this can zoom properly, but anyway, this works from 0 to 250 megahertz, so that's why I need to restrict the bandwidth here. But anyway, this is covering HF and VHF, so it's going to be an interesting result. So anyway, the setup is the following. At the moment there is the input of the spectrum analyzer is connecting to the tracking generator, and the tracking generator is outputting, as you can see, a flat sweeping the frequencies and outputting at minus 10 dB from 500 kilohertz to 250 megahertz. So let me stop the tracking generator now. Okay, and the idea now is to connect the output. We already used this method to check the the reflection of my homemade do-it-yourself 10 megahertz filter. So the idea is to connect, well, let me just do that. So I'm connecting the dummy load to the input port of the coupler. So let me do that. Okay. Okay, that's well done. Now I'm connecting the output of the tracking generator to the output of the coupler here, this way. And finally, the couple port of the coupler here to the input of my spectrum analyzer. So let me do that. Carefully. Okay. So everything should be well connected. These are good cables. So the idea is the following. Signal will go with 10 dB of power from the tracking generator to the output port of my coupler here. It will go through and will reach the dummy load. But some part, even if this is a precision dummy load, some part will be reflected back. And this reflection will be captured with 20 dB attenuation by this port here that reaches my the input of my spectrum analyzer. So let me just triple check that every connection is proper. And then I can start the tracking generator here. Let's start it again and let's see what happens. So start. Right, so this is the response that we get. And as it is expected, it depends on the frequency. So at very low frequencies, you have very little reflections. Here we are measuring reflection at minus 68, more or less, dBms. In fact, this is an attenuated signal by 20 dB because this port here is attenuating the reflection by 20 dBs. So it means that in fact the reflection is about of minus 48 dBs, right? And since our signal, the tracking generator, is minus 10 dBs, there is a difference of 38 dBs. So this difference is called the return loss. In fact, let me actually put here a line, so it's going to be useful. So the line here is at minus 30 dB. So this accounts for the input, which of the tracking generator, that minus 10, and for minus 20 dBs of attenuation that we get here, okay? So now we can simply count the number of divisions, and as you can see here at 10 megahertz we are about 3 division, almost 4 division down. Instead, at the end of the spectrum, at 250 megahertz, we are at about minus 25 dB. So the return loss is of 25 dB. So there is more reflection. And here we can use this tool here to convert the return loss to the WSR coefficient that SWR coefficient that ham radio operators use. So for example, if we put the 38 dBs return loss that we have at around 10 megahertz, we get that the SWR there is of 1.025, so it's fantastic. And instead at 25 megahertz we get this 25 return loss, which correspond to 1.1 SWR at 250 megahertz, which is also great. And in general, if we see the specification of a very high level dummy load, here we get well, let's see, well, here there is only the return loss, but if we go to the Radiall datasheet, yeah, here we get also the SWR, and that is about, as you can see, 1.1, 1.3, so we are within this type of specification, so I'm very happy. So yeah, all in all, I'm very happy about these things. So let me turn off now the tracking generator and disconnect things. Yeah, so thank you very much to the ham radio operator in France who sold me this. I'm very happy. I will make good use of it and in my experiments and learning process. And I'll see you next time. And if you have any question or comments, please feel free to leave them in the comment section below. See you next time. Bye.